They're here. Poltergeist. Good movie. Google it. All right, circles, we're back. Yes, we're back with calculating. Yes, you will need a calculator to calculate the arc lengths and sector areas of circles. But that's only if you need an exact value. You're not really going to need a calculator if you're just putting it in terms of pi. So if you want to put it in terms of pi, you can. Like 2 pi, 16 pi, 1/2 pi, all that fun stuff. We can just put pi's all over the place because we really don't need a calculator necessarily, and here's why. Let's take a look. First things first. Mentally, take a look at this area here. Find the area of the shaded portion of the circle. Well, let's be mental about it, but let's actually be smart about this. The area of a circle is pi times the radius squared. So we can really just say that 8 squared right there, 64 pi. But half of that is not 64 pi. It's 1/2. So if we come on in here, we say that that's going to be 32 pi. That's an expression for the area. And once again, we're not using a calculator right now because we're just trying to get an expression for it. If you were going to go measure it out, you might need to get an exact value, just multiply by 3.14. Same thing down below here, we've got a 1/4 pi times the radius squared. And the radius squared is 6, that's going to be 36 is 6 squared. So 36 divided by 4 is 9. So we can say that that's 9 pi, and that's our area right there. That's covering. Now we talk about surrounding. Surrounding means we're going around the outside. If we go around this circle in this arc right there, that is circumference. So that's when you talk about circumference, you're talking about 2 times pi times the radius. Or you can also write it as pi times the diameter. That works too, but really they gave us the radius, so let's just work with that. All right, let's work it, work it, work it. And we know that we're going to need a fraction of that. In this case, it's going to be 1/2. So this is going to be 1/2 times, I like pi times the diameter. Actually, that's not a bad idea. Pi times 16. You'll notice that that's just the diameter instead of the radius. 1/2 of 16 is 8. So 8 pi. Not bad. And then down here below, we're taking a quarter. So we're taking 1/4 of pi times, and I'll use the 2 pi r this time because it's 2 times 8. It doesn't really matter. I like the diameter's easy. It's just less numbers in the calculation. But you notice that you still get this idea of 8 times 2 is 16. And then you've got 1/4 of that. So 16 divided by 4. Let's see what we got here. 16 divided by 4 is 4. We got pi. So that's the idea. Just shortcut. These are just expressions. So that's how to calculate sector area and arc length. And its arc length, really, it's more about the way around. But you notice those are just basics. Let's go a little further. How about with the angles aren't quite as simple? Let's take a look at here on the left. We've got a radius, we've got an angle, and we're trying to find the sector area. All right, so let's see what we got here. So now we're going to go with the area is going to be 100 pi. And to get this fraction of that, we are going to go with the, we got 3/4 of that circle. So really, we know that it's really 270 out of 360, but that's silly to do that. You just take a quarter of 100, so that's really reduced down to 1/4. So 1/4 of 100, so we got 25 pi in here. All right, that is the best way to do that. And over here we got a 60-degree angle, so we're going to go with the radius of 12, so that's going to be 144 pi. And 60 is 1/6. So that's 1/6 of 144. And if you want to do that on a calculator, you can. I'm going to at the moment. That means this area out here is going to be 24 pi. I am leaving it in terms of pi right now just because I can. And then over here you got, it gets a little, 135, what the heck is 135? Well, if we want the fraction, it's got to be 135 out of 360. So it's always out of 360. That's the idea. Out of 360. And then the area, so it's a fraction of the area. It all comes down to fraction of the area. Now that fraction happens to be an angle measurement out of 360. That's okay. But we got 16 squared times pi. This is where the calculator comes in handy. 16 squared is 256 times 135 divided by 360. We get 96 pi. So use your calculators. They are your friends here. They're helpful. And that's areas. Let's see. They didn't ask us to find the arc length here, did they? Oh, they did. Oh, they did. So let's go ahead and do that. I'm just looking at the question at the bottom here. So if we want to find the arc length, let's go ahead and start it on over. And come on back. And say, okay, no big deal. What's the circumference of that circle A? Well, the circumference is going to be pi times the diameter. So that's going to be 20 pi. There it is. And we want a fraction, so we want 3/4 of that. Well, 3/4 of 20 is 5. So that arc length, remember we're talking about this arc length around, but we're not going all the way around. We're going this far around. That's going to be an arc length of 5 pi. And over here we're going to do the same thing. Except we're not going all the way around. We're just going a little bit around. We're going 1/6 of the way around. So we're going to go 1/6 of pi times the diameter. Diameter is 24, because that's 12 times 2. And the pi is still the pi. 24 divided by 6 is 4. So therefore 4 is going to be 24 divided by 6 is once again 4 pi. And that's our arc length. All right, and the last one here we may need a calculator for, but let's give it a shot. The diameter is 32, 16 times 2 times pi, and then the fraction of that diameter is 135 out of 360, and I know that just like the area, that's a pain, so we got to use a calculator on it. So let's go with 32 times 135 divided by 360, and we get 12 pi. Not that exciting when you're all done, is it? Didn't think so. So coming around that arc length right there is going to be 12 pi. All right, so arc length, fraction of the circumference. Fraction of the circumference. Okay. I know it says build a method here, but we just kind of did that. So it's, if you want to knock it out in terms of just purely, you're taking this angle theta and you're dividing it by 360, and you're always doing that. If you want this sector area, you're multiplying it by the area of the circle, the whole area. And if you want the arc length, you're taking that theta at 360 and you're multiplying it by the circumference. That's how you do it. Again and again and again. So this one, I'm going to skip the details on this, but it's not the heart of a concept. Just get some practice. Do the practice in the book. Do the homework. All right, there's the sector. There's the idea. There's the sector, what it is. It's the region inside a circle. It's kind of a pizza slice. So find the area of a circle, take a fraction of it. You have the area of a sector or pizza slice. And circumference is really just the other way. It's the distance around. All right, pause it. Look at the cartoon. Have a nice day. We kept it under 10 minutes. Take good notes. We'll see you Thursday and Friday, folks. Thank you very much.